Swayam Prabha. Digital India. Educated India.
Hello everyone. In our last session, we have discussed about the Molten metal protective clothing, and it was extreme heat generated by molten metal, particularly iron, aluminum or different types of industries where people work in front of that molten metal. So, we need protection, and that basic discussion we have done. Now, here what we will discuss? We will discuss the one small research study where we have tried to develop molten metal protective clothing using wool and meta-aramid blended fabrics. So, here we have developed this fabric using meta-aramid and wool at different proportion, and also later on we tried to develop yarn of different structures, and both woven and knitted fabrics were studied. Now, let us try to understand what is the problem of the molten metal protective textiles. So, the protective textiles for molten metal is actually protecting our lives in extreme heat environment where metallurgical environment is there. So, people work with molten metal. So, at that industry, those type of industry like foundry worker. Okay. So, safeguarding the foundry workers through advanced material science. So, we have tried to develop, we have tried to develop different types of fabric structure, and one small studies I will try to show its experimental result. So, what are the daily hazard exposures? So, constant threat from radiant heat, basically that we are actually always, it is not that the molten metal will come into contact with the textile material, but constantly the radiant heat it will generate. So, person is always exposed the radiant heat at high temperature. Convective flow is there, basically that air movement is always there, and contact heat exposure. Contact heat exposure, that is the areas which are there, like the handles of this equipment is hot. So, he is actually exposed to contact heat there, and at the same time molten metal splash. So, there may be splash of molten metal which exceeds the temperature of 1400 degree Celsius. So, at that high temperature a molten metal splash may be there on the clothing, and the clothing has to protect us. So, this is the main function of the molten metal protective clothing. So, what are the goals? At this stage the engineering goal is that to develop uncoated metal wool meta-aramid blended molten metal protective clothing that shades the molten metal while maintaining the strong thermal resistance. So, there are basically two main objectives. One is that to maintain the high thermal resistance, at the same time it should shade the molten metal while it is coming into contact with the clothing. If it stick to the garment, then it will burn, and for that we have developed wool meta-aramid blended yarn, which is uncoated. Coating sometimes creates problem. Coating the chemical may help in burning. So, our objective was to create without any chemical coating. How can we develop protective textile which will be thermally resistant and which will shade the molten metal. So, that was our engineering goal, and the value proposition is that we want to balance the EN ISO 11612 and ASTM F955 protection with breathability, flexibility and wearability. That balance has to be there. So, the comfort aspect has to be taken into consideration. Basically, otherwise the protection we can get. We can get the protection with the very thick clothing, but we will not be able to get the comfort here. So, comfort is also very important. So, what are the different types of hazards, that let us try to understand the types of hazards. So, workers in foundries, smelting and casting, in those industries where they are actually facing extreme heat condition, extreme heat hazard condition, like molten metal type of hazard, metal contact hazard, radiant heat and flame also. So, that we have already mentioned earlier. This type of hazard situation is facing always constantly. So, the current protective textiles or protective clothing mainly relies on heavy coating. So, coating try to apply heavy coating which will actually prevent the molten metal to penetrate through the clothing and also to prevent from extreme heat, or what we do, treated fabrics that reduce the comfort and add cost, that is the main problem. So, if we coat the fabric, so if we coat the fabric, like in this case this clothing, if it is coated fabric, what happens? It will block the pores in a fabric, in a clothing, and so breathability will not be there. So, moisture vapor transmission will not be there. So, then we will feel uncomfortable, and also if we add this coating, so that will add to the cost of the product. So, cost enhancement and also it will reduce the comfort, that is the current protective textile. Our idea was to develop clothing without any additional coating, only by making the fabric compact, and also that we can reduce the cost. So, that was our idea, to make the fabric lighter. So, heavy coating if we add, so that will enhance the overall mass of the clothing. So, what we tried? We tried to innovate a fabric solution without any coating, providing the protection while maintain the comfort. That is our main idea, because there is a trade off. If we try to enhance the protection, that will in turn reduce the comfort by making the fabric stiffer, making the fabric unbreathable. So, that in that case the performance will get reduced and the person will feel fatigue within a very short span of time, or he will not be able to wear for long time. So, that is why our idea was to enhance protection, maintain protection, but at the same time to maintain the comfort also. So, the critical temperature if we see here, so molten metal, molten iron or steel industry where catastrophic burn can be there. So, catastrophic burn, suddenly there is a molten metal splash is there, that will typically burn, that person can get burn injury and it can instantly ignite a clothing which is non fire retardant treated. So, if we use normal clothing like cotton, polyester, this type of clothing will immediately get burned, so ignited. So, that burn flame will be there. So, that type of clothing we cannot use due to the catastrophic burn condition. So, this can happen anytime suddenly. So, that is why we should be very careful about our protective clothing, and the molten aluminum, and the main problem is that the aluminum in normal case like in meta-aramid, aluminum it has got a sticky nature, sticky hazard is there. So, in case of iron the stickiness is less. So, here for aluminum due to the stickiness it adhered to the fabric surface, and once it is adhering to the fabric clothing surface, so prolonged heating will be there for in case of aluminum. So, prolonged heat transfer, because it is a molten, so that heat get transferred to the human body. So, that is very important. So, we should not have a clothing where aluminum get sticked, molten aluminum should not get stick to the clothing surface. So, that is important. In case of iron or steel, this type of problem is not that severe. Now, let us see human tolerance temperature. So, pain thresholds, as we have explained before, the pain threshold is typically 44 degree Celsius. Now, if I draw x axis is the temperature degree Celsius, y axis is the frequency of our temperature thermal sensor. If we see the cold, normal cold sensor, here it is say typically say 5 degrees Celsius, and here it may be around 42 degrees Celsius. Okay. And then 45. So, your this pain sensor starts from above say 50 degrees Celsius. Warm sensor. So, warm sensor, normal warm sensor gets its activity is lost above 42-43 degrees Celsius. After that the pain sensor starts its activity. So, if we have more than 40 degrees Celsius, then we will start feeling pain and second degree burn will start. Okay. And second degree burn will start within second at 60 degrees Celsius. 60 degree if we sometime our skin temperature reaches. So, within seconds it will give the second degree burn, but pain will start above say 44 degree 45 degree Celsius. So, our human tolerance, we will lose our tolerance if the skin temperature exceeds 44-45 degree Celsius. So, our molten metal, when it is in contact with our body, that temperature increase we should not allow. If it gets shed out immediately, then the temperature will not be increasing to that extent, but in case of molten metal like molten aluminum, if it stick to our clothing, then the prolonged heat transfer will be there. So, our skin temperature will reach above 44 degrees Celsius and or maybe say around 60 degrees Celsius. So, that second degree burn can happen. So, this development is important where the molten metal, particularly aluminum, should not stick to our on the clothing surface. That was our priority. And secondary risk and mitigations are, what are the secondaries? Heat stress. Heat stress is there. So, in that case we should have proper breathability in the clothing, otherwise this will create heat stress by accumulating the moisture vapor within the microclimate. So, overheating reduces the cognitive function and reaction time. So, that is very important. So, our body should not get overheated. That was our one of the ideas, to create the pores, so that body heat can be released through the moisture vapor. If it is coated, then body heat cannot release easily, and also the heavy clothing or stiff clothing will restrict our body mobility. So, that will also difficult. So, we have to develop our clothing taking all these things into consideration, where heavy stiff PP increase the accident, like it is it will get accident, so create accident. So, that so basically the problem is that the person will be overheated and it will it may increase the other problem, enhance the other problem along with the problem of the molten metal. So, this issues we have to take into consideration while developing the cloth. Clothing should be flexible, it should be light. Okay. Here what we have used a natural fiber, wool. Normally people used to use the coating on some other different types of fibers like your meta-aramid with high temperature resistant fiber, but there the problem is there, meta-aramid with the aluminum can get stick on the surface, that will prolong the heat transfer. So, why did we select wool? Well, we have selected wool or wool blend with the meta-aramid. So, why we have selected wool? Main advantage of wool is that it is stable and insulating char formation. So, if we use wool, so wool will create char when some molten metal come into contact, it will create the insulating char, and that will prevent the heat to come into transfer through this char. So, it will increase the thermal resistivity. And another advantage of wool is that it is a self extinguishing, that is relatively higher LOI value. So, typically 23% LOI. So, that is supposed to be a good LOI, it will not burn on its own, that is the advantage of wool here. And most advantage is that, most important thing is that no molten metal addition to the surface. So, we will discuss why molten metal does not get stick to the wool surface, that part we will discuss. And also only wool if we can use without any coating. If the 100% wool or wool blend without any coating, then the advantage will be that wool is also by nature, it is a hydrophilic, it absorbs moisture from the body, and you can have open structure without any coating, not so open, although fabric will be compact, but in between the yarn there will be pores because it is not coating. So, it will enhance the breathability and enhance the comfort, okay, because it is a soft, okay, moisture absorbent and pores are available. So, it will enhance the breathability. So, that is the advantage. These are the reasons the wool is actually can be used for molten metal protective textiles. And the another important thing is that it is a sustainable, it is a natural resource. So, it does not actually add to the additional carbon footprint, it does not. So, it is naturally degradable. So, we can have sustainable product. So, the advantages we can summarize once again. It is basically, it forms the insulating char formation is there, so that it enhances the thermal insulation, and which is stable in nature, it does not change. Self extinguishing, it does not burn on its own. Molten metal addition is not there. So, molten metal when it drops, it can shed out immediately. It is comfortable and breathability is there because of the structure, because of its hydrophilic in nature, moisture absorption, and its natural resources, it is sustainable. So, with all these advantages, we have selected wool as one of the components. Now, why meta-aramid we have used? Meta-aramid is used mainly because of its high temperature resistance, high temperature. So, it withstand high temperature, like prolonged time, you can have up to 400 degrees Celsius without any degradation. So, that is the advantage of meta-aramid, and it does not melt or drip. So, it forms little bit char formation is also there in case of meta-aramid. So, melting is not there. So, dripping and melting problem is not there, unlike synthetic fiber like polyester, nylon. Self extinguishing, it has got higher LY value. So, the main problem with meta-aramid is that the molten aluminum it sticks to the surface. So, that is the problem here, and it is a chemical and environmental resistance. So, this does not get reacted with the normal chemical, or in environment it does not get degraded quickly. So, that is a advantage here. But the problem here is that the molten aluminum get adhered to the meta-aramid surface. So, this is the problem here. So, it has got advantages. So, some advantages are over the wool, like high temperature withstand, it can do prolonged temperature withstand 400, which is better than wool. Do not melt and drip. So, it is equal to wool, this is better than wool. Self extinguishing, it is higher LOI, better than wool. Chemical and environmental resistance, much better than wool. But the advantage which wool is getting, that molten metal does not stick to the surface, but here in case of meta-aramid, molten metal stick to the surface. So, our approach was to use the positive points of both the fibers. Wool has got advantage of that, it is comfortable in nature due to high moisture absorption. So, we tried to use the positive attributes of both the fibers and develop clothing of blended yarn, blending of meta-aramid with wool with a different proportion. So, now the why, as I mentioned, why we have blended. So, the power of the blend is that you can see the blend power. So, blend is how the property gets enhanced, and why we have taken the wool and meta-aramid as a components for blending. So, metal shading, wool has got very good metal shading, and meta-aramid is very poor in metal shading, it is poor, it is stick. So, wool at aramid, if we blend, taken the advantage of wool, we will get superior quality, and if we increase the wool proportion, we have found this metal shading characteristics improved. Thermal stability, for this wool is moderate, because at high temperature resistance it may degrade at a very high temperature, but 100% meta-aramid it gives excellent thermal stability, and if we blend these two, we will get very good, very high thermal stability. So, we are taking advantage of meta-aramid to get the thermal stability. Comfort and breathability, For wool it is excellent, high or excellent, very good comfort and breathability we get from wool. Why is it comfort and breathability we have said not excellent, high? Because we are, our target was to use little bit coarser wool, okay. So that the comfort level little bit reduced, but it is much higher than the aramid fiber. Aramid is low. So, if we blend we will get optimum comfort, which is minimum requirement. So, heat metal shading we are getting superior quality, high thermal stability and optimum the optimum comfort and breathability that we are achieving. And charge strength, this is here the charge strength is actually in, if we use 100% wool, the it will be brittle and it will get off from the structure. So, total structure will get destroyed when there is a metal drop is there. So, char formation will be there and it will form in case of wool due to its chemical changes, it may be it will become brittle. So, that it will totally come off from the structure, from the clothing. But in case of metaramid, charge strength is strong. So, due to high thermal stability, so it will not get fabric will not get destroyed. So, which will help in reinforcing the clothing, wool aramid, metaramid blended. So, it will give the reinforced charge strength. So, that is why these are the reasons we are using the blend here. So, blend of metaramid and wool is recommended here due to all this, that the advantages we are getting. Now, we have to actually solve the classical problem, the trade off problem. Do we need protection or we need comfort? So, protection is always required for any protective textile, that is, and that this paradox we have to solve, comfort protection paradox, that problem we have to solve. Now, the traditional limitations are, we use heavy and bulky cloth to make us protected from the molten metal. So, use heavy cloth, bulky, coated. So, that main paradox is that if we are using the heavy and bulky cloth, the problem would be it will be thicker and thick layers and coating will restrict the body movement. So, body movement will get restricted and the breathability will be lost and it will increase the physical load. When body movement is not proper, it is not free movement, then person is working, he is active in front of molten metal. That means, the physical load on the human will increase, because to bend his or to make any movement, he has to impart certain extra load. So, that will actually physical load will be enhanced. Now, heat stress risk. So, why heat stress risk will be there? Because the loss of breathability. So, poor breathability, because the clothing, if it is coated, heavy clothing, if we are using heavy bulky clothing, that means moisture vapor transmission will not be free. Moisture vapor transmission will take longer path and it will not be easy. So, that will actually trap the body heat. So, if vapor cannot transfer easily, if the vapor cannot transfer easily, so it will trap the body heat, it will not be able to take the body heat out. So, that is very important, and which leads to rapid fatigue and dehydration. So, that person will start actually dehydrated, because he will start sweating. So, moisture vapor, if it is passing through, now let me draw and explain. Suppose this is a human being, okay, and here is a fabric coating is there. So, let me draw human being, and say fabric coating is, this is the fabric, thick fabric coating, molten metal coating is there. So, the different thick layer we have made, okay, traditionally. Now, what will happen? The poor breathability, that means the moisture vapor which is going releasing, initially the moisture vapor is getting released, that is not transmitting easily because of the thickness of the clothing. Okay. And in that case, what will happen, as it is not evaporating, moisture vapor is not getting evaporated easily. So, body will get heated, because the external environment is very hot. So, body will get heated, because through the moisture vapor the latent heat is not getting transferred, and in that case what will happen, the sweat will start generating the sweat. So, sweat, because the body core temperature has increased. So, next phenomena will be sweating, and profusely he will start sweating within the, and it will start dripping, it will wet the cloth, inner cloth, and that will result the dehydration, because unnecessary liquid fluid loss will be there, and the person will reach fatigue rapidly. Say in normal clothing, when breathability is there, proper breathability is there, in that case if you can work for 2 hours, if breathability is not there, he will reach at the fatigue point within say 10 to 15 minutes. So, that is why proper moisture management is very important, particularly for this protective textile which at high heat stress condition. Okay. So, that is very important, and then if he is fatigue, if he reaches fatigue easily, what will happen? At this point he will not wear the clothing, he will remove the clothing and will be under threat. So, compliance will not be there, discomfort leads to the worker removing the gear, protective gear, or wearing incorrectly. Maybe the condition was that he has to close all the buttons, but to enable the heat to move easily out, or to enable the moisture vapor to move out, he may actually open few buttons, which will actually compromise the protection. So, that is very important, and looking at the traditional problem with the traditional protective textile, the next generation solutions are the breathable structure. So, we should create a breathable structure which was not here in traditionally. So, how breathable? By creating the pores within the fabric. So, uncoated fabric. So, if it is say coated, so if it is coated, the coating will actually block the pores. So, our approach was to create a breathable structure, that is uncoated weave, no coating will be there, and if it is uncoated, then it will allow the moisture vapor to escape quickly. So, it will be breathable and finally, it will cool down the wearer. So, that is the main advantage of this type of design without any coating. So, for any high stress condition, the coating is not recommended. Coating means totally blocking the pores, but we can coat the individual fiber with any different thing using say nanotechnology. We can coat the individual threads also, but not the fabric. And also enhance the ergonomic mobility. So, next generation solution is that one is the breathable structure we have to make, we have to create the thermal protective clothing by using proper high performance fiber. Also the ergonomic mobility. So, we have to design the clothing so that the protection is maintained and also it does not restrict the body movement. So, flexible fabric drape improve the body motion movement and reduce the exertion. As I have mentioned, if the body movement is not free, then body will be loaded unnecessarily and it will get exhausted, so it will get exhausted easily. So, the safety is required, but you should go via clothing comfort. Without comfort, you can, if you try to achieve safety, then the problem would be that the all this that low compliance problem will be there, the heat stress will be there. So, that we have to see to reduce the fatigue. The reduced fatigue maintains the cognitive focus, that is important. If the person is not fatigued, he will focus on its body movement, he will focus on its work, he will be faster, he will respond faster. So, that comfort ensures full shift to compliance. So, body fatigue will be reduced, which will maintain the cognitive focus, and then the when the person is comfortable, he will focus on the activity and he will focus on the compliance of that. He will not remove the cloth, he will maintain all the standard compliance protocol to keep him protected. That means, the fabric is protective textile, but comfort you have to incorporate there, and our idea here is to maintain both this comfort and protection. So, that was the basic idea. Now, let us see the char formation mechanism for particularly for wool. So, in case of wool or meta-aramid, no melt formation, no drip formation. That is important for high temperature protective clothing, particularly for this molten metal protective clothing, because molten metal, when it comes into contact with the clothing, if it melts, then there will be problem, and it should be, there should not be any drip. Like polyester and nylon, that get melt easily due to the lower melting point, and due to their lower melting point, and which cause severe contact burn. Like a polyester fabric, when it is melted at high temperature, that will stick to our body, and it will generate severe damage, it will transmit more heat to the skin to inside the body. So, severe burn injury, contact burn injury will be there, and whereas wool and meta-aramid undergo solid state carbonization, that is char formation is there without any melting. Before melting, wool or meta-aramid, they form the char through the solid state carbonization, and which creates the dry structural scaffold. So, that type of insulating scaffold will be created, which is dry. Molten metal, after melting, it stick to our body, and that creates severe burn. So, no char formation is there, no, that is no melt and drip is there, but proper dry and insulating char formation is there. Like natural swelling is also there. Intumescent expansion, that is swelling, natural swelling will be there. You can see upon heat exposure, the wool component releases the moisture and nitrogen gas due to the heating, and causing char layer to swell, that it moisture and nitrogen gas it releases when it is heating, and the char formation was there already on the surface, and that layer swells, that expands. So, suppose this is the char, for this is wool fiber, wool fabric, and above that there is a char formation, this is a char formation, okay. And here when it is heated, during this process, it releases the moisture and nitrogen, and this moisture presence, it actually swells the char. Let me draw once again. This is the clothing, and the char, if you see, after swelling it will become, char become swelled, and it is thickened. Thickness of the char increases, and which will enhance the protection power. So, the thickening, this thickening creates trapped air pockets that drastically lower the thermal conductivity. So, here air pocket increases, and it will immediately increase the thermal conductivity. So, the person is protected more. So, it provides higher protection due to the swelling or expansion. And for aramid backbone, while wool provides expansion, the metaramid maintains structural integrity. So, as we have mentioned, it is structurally it becomes stable, and wool is expanded, that due to the char formation it is increasing the thermal resistivity, lowering the thermal conductivity, and this char whatever it is formed, that is normally for in case of wool it is a brittle. To keep the char stable, when we blend the aramid, if it is aramid is there in the char itself, suppose this is aramid is there, aramid helps in the strengthening, it is actually structural integrity it mentioned, preventing the char from cracking or breaking open, okay, and under the metal splash. So, metal splash is there, char should not actually be broken, otherwise the total the structure will get destroyed. So, main problem with aluminum, as I have mentioned, its aluminum adhesion is there, that is a critical safety risk. So, how does aluminum get sticked and why does it get sticked? Let us see. So, aluminum has got main problem of adhesion, threat from the adhesion. So, molten aluminum, so around say 660 degree Celsius tend to wet and adhere strongly to the standard synthetic fiber. For any synthetic fiber it gets stick to the surface, even for the high performance fiber like metaramid also. For normal synthetic fiber it gets stick to that. This create heat sink and affects the fabric surface. So, when it is actually adhered to the structure, it will create heat sink and the effect is on the fabric surface. But in case of wool, the main advantage is that it is actually, it has got scales, epicutical scales are there, which create natural microscopic roughness. So, scale is there which creates natural roughness, and microscopic roughness is created here, and when the metal drop falls, it increases the contact angle. So, contact angle is reduced. So, for a normal fabric, let me draw, say for metaramid, this is the metaramid and here this is the wool metaramid. Here when the molten metal drops, or wool, it is there. So, here the contact angle will be very high for wool. This is due to the presence of scales, microscopic scales. microscopic scales are there which helps in increasing the contact angle. You can just we know the theory of lotus leaf effect, where the contact angle is very high, that is due to the nano level this type of roughness. Okay. So, here microscopic roughness is increase the contact angle of the and which cause it to bead formation, not the actually the sticking to that, it forms the bead formation, and this bead will in fact if eventually roll off the surface. But in case of low contact angle like other fibers, it will try to stick to the surface. That is the advantage of wool is there. Even for meta-aramid, it stick to the surface. So, there are different literatures available. So, we try to search the literature, we have survey the literature for last few years, maybe last 30-40 years we have started looking at the way in which direction the research people have studied. Now, in 1986 one research group they have studied that wool contribution to the worker safety against molten metal. They have actually studied on the molten metal safety on wool. Okay. What they have got, the result was that wool demonstrate 20 times superior molten metal protective protection. 1986 they have. Okay. That is wool can withstand typically around up to 500 gram molten metal versus 25 gram for aramid fiber, normal nylon, any aramid fiber through metal shading and insulation char formation. So, wool is superior. They have got another in 1997 protective performance against molten iron. So, they have studied on the protective performance. What they have got, that they have on the knitted structure, okay, effective in underwear application with wool blend needs achieving certain level of protection E2 and E3 protection while maintaining the comfort. So, wool blend they have proposed, and 2008 molten metal resistant fabric. So, there is a patent where it is saying 40% wool, 20% meta-aramid and 40% FR viscose. So, superior molten metal for aluminum molten metal protection. So, due to the presence of 40% wool, so it actually gives the protection as well as the molten metal shading advantage it will provide. Wool meta-aramid blended fabric was developed. So, 50-50 wool Nomex blended lightweight flame resistant fabric, and they have done the plain woven fabric. Only 12.3% skin burns are there in mannequin test, meets tough military protection. This was actually by US Army. Next is in 2020 workwear fabrics were developed and under molten metal. So, meta-aramid alone provide inadequate molten aluminum protection, that is there, because that is due to the sticking, due to the fiber softening and molten adhesion. So, 100% metal aramid is not in use. So, another 2021 knitted flame resistant wool aramid fabric. Wool aramid fabric again was studied under for US Army. So, 50-50 wool aramid blend was used, which is cost effective than poor aramid. Aramid is very expensive and it enhance the breathability. Okay. Another study was thermal protective performance of rib knitted structure, that is actually with the different types of compactness it was studied. So, we found that there are different types of studies available. Even latest study was that protective clothing against steam and molten aluminum. So, special fabric was taken, which is FR viscose, para aramid and PVC. So, that they are reporting that outperform the pure para aramid, that is there within their study limit, and knitted structure cause high thickness, mass per unit area and air pocket insulation, and that what they have reported that it gives better thermal insulation against the molten metal. So, these are the few research reports are there. So, the research gaps, basically if you see, there are different research gaps. Based on that we have formulated our research, present research, and that we will discuss in the next session. Till then, thank you.